Okay, hey everybody, we'll start right now. Welcome to your second tech talk of the day. Right now we'll be covering Debugging 101 with Neelima. And so for this tech talk, please save all questions till the end so we can finish the presentation, okay? Thank you.
Thank you. Hi everyone, my name is Neelima. I've worked with VMware for the past 9 years, primarily on a lot of debugging. And right now I'm with ContainerX working on a container management platform. But I've done a lot of debugging in the past 9 years, and we've found it across different problems, across different platforms. Even though the tools and techniques vary, there's a common set of themes that arise, and that's kind of what I'm going to be talking about today. Right, so let's start with a problem, a very simple problem, which turned out to be not even a bug. Right? But it took us a long time to identify what this problem is and how to provide relief to the customer. So we had a customer calling and say, help, the VM console is black. We can't see what is happening. So how do you help out? How do you solve this problem? First of all, what is a VM console? Right? What are you expecting to see? How are you connecting to it, and what's happening? You need to understand that. So this is the system that the customer was connecting to, and that's kind of the console that we're talking about. The user connects to the console to talk to a VM running on a host here. So anything on the path which provides the connection, which is this whole thing, or the direct connection from the client to the host, could be broken. So we don't really know what is wrong. But when an issue comes in like this, it typically comes in as, okay, the component that the user is connecting to is not working. It goes to a team that handles that component. The team looks at it, looks at the logs, and says, it's fine from my side. Right? You're giving me something, and I'm giving you what I expect I should be giving you, and it works good. So go away, go to the next component, talk to the vCloud Director team. They say, it's fine. I mean, we are connecting you all the way through. We're giving you the VM. It's just that you're seeing a black screen there. And so on, it went for a couple of months till it came all the way here to this team, which is what I was part of. And so we said, okay, it's not connecting, so what's happening? What do you even mean by a vCloud Director? I don't know. I mean, you're 3 products up from me. I don't know. So draw me this architecture. Tell me what you're trying to do. Show me where the customer is, right? So that's kind of the very first problem, the first step in any problem that you're trying to solve. Define the problem, understand the system. Right? So tell me, who are you? Who's trying to connect? What are you trying to connect from? Where are you located? So are you connecting over VPN? Are you connecting across a firewall? What is there between you and the system that you're trying to reach? What are the different mechanisms available, and how are you connecting? So here, if you go back to the diagram, you could connect to the same VM from ESX. You could connect it from vCenter. And there's another console here where you can see the VM, and this was working fine apparently, right? So you could connect from here. So how are you connecting, and which path works, which path doesn't work? Usually we only see what works. We don't really look at the part that is still working, and that's usually a very valuable resource to be able to compare and say, okay, this is what is working and this is not what is not working. Define the problem as precisely as you can. And for simple problems, that kind of reveals the answer immediately, right? So here it turns out you were connecting as a specific user, as a vCenter admin from here. You were connecting as a VCD user from here. Both of them had permissions to connect to the VM, but this user did not have permission to view the console. Very simple problem. We didn't have to fix anything. It was documented that when you configure your users, you have to give them these permissions. And we just had to go and give your user the permission, and you could work fine. But it took us 3 months to get there. Right? Nothing to fix. So first, the key learning, and this comes across every problem that I've seen, is understand the problem, understand the system. If any of these pieces are missing, then we just spend days and days and months in trying to find the answers. So what do we mean by understanding the system? So at a very high level, you need to have that architecture diagram of whatever you're working with. Your product may be one small thing that you're working on, but it works in an ecosystem. You integrate with authorization providers. You may have an Active Directory somewhere. You may have an IP address provider somewhere. You may have someone consuming your API. You need to understand the entire ecosystem of what the customer has set up and through which they're accessing your system. If you're working on a specific programming language, learn it in depth to the extent that you can possibly do. If it is one thing is your core, learn it. How does the compiler work? How does it translate to machine code? What does the stack look like when something crashes? What are the debugging tools available for you? What are the performance monitoring tools, profiling tools? Everything that you can possibly get your hands on, learn about it in depth. Learn about the frameworks that you're using. I mean, today afternoon we're going to be having talks on Docker, Node.js. Each of these things are tools that helps us solve a big problem just by doing a very little piece of the code, right? But then you're using a framework, and if you don't understand how it works, you're going to run into issues and issues and issues, and you're going to be debugging them one at a time. But if you spend the time up front, invest it to learn the frameworks, it will make it so much more easier to debug and answer these problems. Understand fundamentals of how operating systems work, how networks work, how storage works. Even though you may be writing a web application and maybe you're designing UI, you need to have some level of understanding of these fundamental infrastructure elements to be able to solve problems in the best possible way. Right? And finally, even though most of us are not interacting with hardware on a day-to-day basis, you need to understand how the hardware works, because everything runs on some real hardware. You need to understand how caches work, how your processor works, what are the different instruction sets available, are you using the most optimal one. Maybe you have to code an assembly for one specific task, but maybe you won't use it ever again in your life. You still need to understand how it works at a high level at least. Alright, so from that very simple problem, which is not even a bug, let's get to a real problem, which took us 3 months to solve. And this is indicative of a class of problems that we've seen a lot in VMware. And there were two main problems that I worked on, very similar ones. And the one previous to this took us 5 years to solve. And this one took us 3 months. I'm going to talk about it because we took all the learnings, put it into the process, and it's easy to illustrate what we went through. So this is the issue. A customer calls and says, I'm seeing the blue screen of death. My Windows computers are crashing. Right? How do you solve it? Your operating system is crashing. It's running on a virtual machine, running on VMware software. But it could be a problem with the operating system. It could be a problem with the software inside the operating system. We don't really know what's happening. And all we see, all we get out of this is this specific thing which says there's a page fault. A page fault is a normal occurrence, and a page fault causing a crash means you're not expecting that page fault and you don't know what caused it, right? So we need to understand the problem, going back to the same thing again. What is crashing? When is it crashing? It's a very rare occurrence. It happens once in 10,000 times maybe, once in a month. Not in the same customer environment. We're getting calls from different customer setups, right? Across each customer side, it comes back as a slightly different thing, but maybe that page fault code remains the same. It happens on multiple Windows operating systems. So we start thinking, is this a Windows bug? That's our favorite thing to blame the operating system if you don't know what's happening, right? And then after about a few weeks of these things coming in, we see there's a Solaris crash too. And it looks similar. There's a kernel panic, and it is a page fault, and we don't expect that address to have a page fault. It's a valid address. If I look at the dump in my debugger, it's a valid address. So why is it crashing, right? Something is corrupt somewhere. Maybe our software is doing something wrong. Right? So we believe our software so much that we come to the conclusion that our software is doing something wrong after we start suspecting the operating system, right? So now we see, okay, when is it happening? Initial reports were on the latest release, so we thought maybe something we are doing is wrong. And then we see older releases are having these reports come in too. Everything is failing, so maybe the hardware is wrong now. Right? So we started looking at the data, looking at and seeing what are the specific processor models involved, and there was a pattern. Slowly we could see a pattern. So we did a lot of data analysis, analyzed every dump that came into our system, not just things that came as a blue screen of death or a kernel panic. Things that came in without a dump but which had a log file saying there's a panic. And we pulled out the specific data. So you have a bug. Now what do? You have customers threatening to pull out of $10 million deals. So what do? First thing, don't panic. Right? Because that is our instinct. We basically want to just go fix something in our code and get it working, or disable some mode that we think is causing the issue. And we did this in our 5-year previous bug, where we thought there's something wrong with our code, let's fix it. And each time we went fixing one small thing, and it never resolved the bigger problem. It just made it harder to find. Right? So don't panic. First, try to identify the root problem. What is the root cause of the problem, right? So first thing we have to do is to recreate the failure. There's a small video at this time, if I can get to. All right. So the bug is like this. You're trying to reproduce it. You can't catch it. Right? You want to catch it in action, you want to see what's happening, and you just can't catch it. It keeps popping up and going off, and it's just bazinga, bazinga, bazinga all the time. Right? All right. So we said we need to know, right, when does he come up, what are the conditions that causes this thing to pop up and crash, and go back to the data analysis. Go deep, go wide, right? So we look at what the crash shows, what are the things running, what is the specific type of address that is causing the page fault. Are we changing maybe something just before this happened? Look at the data, first of all, to identify and isolate the set of crashes into some category which is more likely to fail. So the specific set of processor models, specific workloads. At this point, it's not a one-man effort anymore. It's not even a one-company effort. VMware, Microsoft, and hardware vendors, operating system vendors, multiple groups come together from each of these companies, sitting together and brainstorm. What do we think the data is showing, each of us from our perspectives? What do we think could be a cause, right? So coming up with a cause is a very tricky thing, because your intuition says maybe the hardware is wrong. Right? So if the hardware is wrong, what else would we be seeing? Similar to saying, okay, if the hardware is wrong, you should see it on other hypervisors. You should see it on other operating systems. Would you see it only on a kernel crash? Would it happen in an application fault? Would there be corrupt data somewhere? Right? So what are the other things that could be happening if this were the root cause? Identify all those things, collect the data to identify if that's happening, and we got it down to a specific workload running on a specific set of hardware models, which could recreate the problem once in a week. But we have something. It's not like you have a once in a month one customer reporting. Now that we have some kind of a repro, you start doing a narrowing down onto what is the specific thing that is crashing, right? So you start doing divide and conquer. If this were your code, I would just do a binary search. If you think it's a code and you know at some point you start failing. Here you don't even know where it is failing, so you're starting to divide and conquer in terms of the components involved, and slowly start narrowing down to what could be the one that's causing the crash. And each time you recreate the failure, you start collecting more and more data to help you define what is that boundary that you're going into. So you collect data from all angles, software instrumentation, hardware dumps, and you start so we started identifying that hardware assisted memory virtualization was necessary for this to happen. Only when that was there in the picture this would fail, and only on specific versions, at which point we kind of identified the problem. So once you know the problem, we had a fix. Well, before we got there, we had to document everything, right? So this is a 3-month effort, and if I ran one experiment and you come back and ask me tomorrow or after a week, did you try this? I don't know, right? And it's a group of people. Did VMware try this? Did somebody else try this? Everything had to be documented in detail. Every time you change something, we document what we changed, whether it reproduced the failure or not. If it reproduced the failure after that change, that means that change is not relevant. If it does not, it means we don't know anything. Right? And somehow we finally got to, okay, this is the root cause, at which point we said, okay, let's get a fix ready, test it in our system. Once in a week, we waited for 2 weeks, okay, it's working fine. Give it out to customers, try it out in the field, finally done. I mean, success, we solved the problem. So what is it that you learn? What is the method to the madness here, and what is the process that we seem to consistently follow without explicitly calling it out as a process? Is it clear? Can you see the thing, or I can read it out loud? You can, okay. So first, define the problem. As I said, that's the most important thing. If you just take away one thing from here, when you get a bug, instead of starting working on it with what you think the answer is, first ask what is the problem, exactly find what is the problem. Understand the system, collect the data. Before you start creating hypothesis, first collect the data and then brainstorm, right? Try to reproduce the failure as much as possible. I mean, if you're working in maybe a nuclear industry, you can't recreate the failure, you don't want to. In that case, you want to collect the data before you have to recreate the problem. But if it's a software that you can take a chance on reproducing the issue, first recreate the failure, catch it, then collect the data so you know exactly the data belongs to that problem. Identify the potential causes, make sure that whatever you're seeing or whatever you think the cause is, whatever other effects it have, they are also there, so that you know for sure that this is really the potential cause, right? And then you divide and conquer, zero in on the exact thing that could be causing the problem. Track every little change you make, however minor you think it is, right? I change one line of code, I create a new binary, maybe the layout and memory of the thing changed, and that's enough to disrupt the system, enough to not create the problem. It didn't fix it, it just didn't create the problem, right? So you need to track every little thing you change and recreate the failure after every change that you have done. And then when you think you have a fix, test it, right? Recreate and test and make sure you've tested. Until you've tested, even if you know for sure that is the root cause, you've not fixed the problem. Because it's likely that there is something else that is also a problem, but that is not the problem that you were seeing in the first place, right? Diversity rocks. I can't tell you how many times that we have worked on these issues that you've had such a diverse set of people contributing to it, right? You need people who are experts in recreating test setups, who are experts in digging through the data and identifying these patterns, who are experts in the processor design, in the system that you have, the virtualization software. There is no one person who can understand this entire ecosystem. We don't have Sherlock Holmes. So all of us together is the Sherlock Holmes, and we need to have a diverse group of system. Like even Sherlock Holmes couldn't do it alone, right? Hercule Poirot, he needs Hastings, right? Everybody needs someone to talk through. Even if it is a very simple problem, one person who can solve the problem. Even then I would say talk to your neighbor, talk to someone, find someone you can brainstorm with. If there's no one, talk to a rubber ducky. Explain it. Explain it so that you're talking through, you're saying what is the problem, what do you think is the hypothesis, and maybe you'll get an idea then in the process. For me, sleep works. Right? Anything that works for you to take your eyes off the problem as you're seeing it in that angle, get a fresh perspective from a different person or from yourself, do it, and it almost always helps. Design for debugging. So you know there's a problem, you know how to approach it, right? But if you were starting fresh, if you were creating a piece of software, what would you do to make it easy to debug the problem? First thing is accept that all software will have bugs, all hardware will have bugs, right? So assuming we have bugs, then we need to start treating the debugging methodologies as products. Nobody pays for them, but without them you wouldn't be able to sustain your product, you wouldn't be able to support your customers or enable them to use your product, right? So you have to make sure that you have tools built in, log log collection mechanism, monitoring tools, configuration collection tools. How many systems have you seen where if someone calls you saying something is wrong, you can collect their entire configuration and you know exactly what they're talking about without asking them, where are you sitting? What color is your seat? There was actually a story where there was a bug that could only be reproduced if the person who was working on the system was wearing a checked shirt. because it was a video processing software, and when you were wearing a checked shirt, it had a lot more data to process than when you're wearing a plain shirt, so it would replicate every other day or so, right? So how could, obviously you can't collect the information about what color shirt they're wearing, but leaving that out, what all data can you actually collect automatically without asking? Because people always come from a frame of reference. They'll only tell you what they think is important. Okay, so build in all these things as much as you can, and given a configuration set, how easy is it for you to replicate the setup? The first issue that I talked about, the VCD setup, a lot of us in my team didn't even know how to set up a VCD server, right? We couldn't even recreate end to end what's a working scenario in this case. Why should it be hard? Right? If you have a configuration, you should just be able to replicate it immediately. Build it like that. Create stress options so that you know something happens only in a low memory case. You don't want to have to wait till your system is running low on memory to start debugging the issue. Create a tool that will make you get to the system which is low in memory directly, right? So build in those stress test options and treat your debug tools as products. We've been in countless situations where you're debugging something, you give a monitoring tool to the customer, it crashes the customer setup. Why? Because debugging is something you do while you're developing, maybe while you're testing, and you don't really think of it as a production product. It doesn't go through the entire test qualification cycle, right? But just imagine the customer experience. I have one system crashing, I give you a tool, you have my entire setup down. Right? So you have to start treating the debug tools as products and build them rock solid and give them to the customer, they should be able to work. And then one more thing, a very interesting piece of software I think that all of us have used is ping. What does ping do? If you have one computer, you're trying to connect to another computer. No matter what is there in between those two computers, it tells you, is it reachable? Can you design a ping for your system? Something that says if the user is sitting in front of your system, it goes and touches whatever it needs to touch and comes back and says, yes, all is well, everything is working as designed, and you can use it, right? Can you design something like that from the get-go so that you know it's working? First of all, when someone calls you, is your setup broken? Maybe one of your server is down, or maybe your network is down. How many different pieces are there that the user has to go and manually check? Instead of that, can you make it simple and say it's working? Right? So that is how you design for debugging, right? But there's a fundamental aspect of being able to debug, especially in a customer environment, is to have them continue to function while you're debugging. If you say you have to bring your entire production system down while I do my debugging, I'll attach a debugger, it's not acceptable in almost all cases. So design workarounds, design feature switches. So if you just ship the latest product which has the greatest optimizer in it, and it's great for 99% of the cases, but 1% of the cases it crashes the system, you want to be able to turn it off immediately and say, okay, while I work on it, you can still function, maybe with a degraded performance, but you still want to continue to use the system. So create workarounds, have these workarounds and features which is thought of when you're designing a feature. All right, happy debugging. I'll be happy to take any questions, and I think I'll like to leave with this slide basically with the key takeaways that you want to remember, keep in mind when you're debugging.
What are some of the best tools you found that have helped you debug?
So as I said, breadth helps a lot. So I've debugged on Windows, Linux, different operating systems, right? If you have debugged ever on Windows, I think you should know the sysinternal suite, right? You should be able to have whatever is your process monitoring tools. You should be able to trace through, if you're doing device drivers level, you should be able to trace through where each call is going through. There's something called Xperf, which is awesome with profiling Windows applications, and so very specific to a specific ecosystem. So I'm talking about Windows here. So if you go to Linux, I don't know what I would do without strace. Right? Very simple, but it lets you know what exactly is happening. So if, let's say you have a configuration file that's missing, just run your program with strace on and you'll see somewhere where something says file not found, and you can see why that error is happening, and then you can immediately identify the problem, right? There are lots of debuggers again. I mean, if you're on Windows, WinDbg, if you used, how many of you here are kernel developers and how many are application? Okay, so so basically it's very specific to your ecosystem, but then I think having that breadth of tools always helps, because it kind of helps you narrow down, and then you can use whatever is specific to your ecosystem. What is your primary development platform?
Well, I've worked on different things. I was looking for general tools,
General
but it's always on, it's been now on Mac. So, there's actually a lot of different things working on. So there's some, I'm getting into Node.js, and then there's like a lot of Java applications, web applications, REST API services. So quite a lot of different things. So there's pretty much any tools I'm just, looking at.
I mean, I've recently looked at a few front-end issues, JavaScript issues, developer tools on Chrome. That's an awesome
I use that.
resource, right?
Yeah.
So there are lots of things. I mean, specific to what domain you're working on, there are lots of things, and I think that's part of understanding your system, knowing what tools are there, and talking to the people who are there around you who've worked with different tools, right? But most of us have different backgrounds, and if you bring them together, you'll have a much diverse set of resources as well.
Do you usually get some buy-in from your management for making the debugging tools good quality, or?
It's very hard. It's actually an uphill battle to do, to be able to invest on debugging tools, because typically they start out as an individual developer. You're building something and you need to debug it, so you start creating a debug tool. By the time management really realizes the value of a debugging tool, you've probably had a couple of fires in the field, and they know you really need it now, and that's when they start investing. And I guess till then you just keep educating people on how important it is, and hopefully you can have those in place before you have the fires. Yeah. Anyone else has questions?
So how would you scale this kind of methodology to production issues, like where you literally don't have time to do all the data analysis, collect patterns? Typically what I've seen, they just restart everything. Is that the way to, is that generically accepted? Like, I don't know. I mean, I've seen a lot of companies do that.
So I would say, I mean, if you have to keep your production environment going, and if that's what you need to do, go ahead, do it. But before you do it, make sure you have the data to analyze it off the production environment, so that you can actually fix what is the real root cause, right? There was an example from, I think, Facebook. So where they had an inbuilt mechanism to actually restart the services if something crashes, and so they had services running out of memory that were getting restarted, and that caused a cascading effect of multiple servers getting restarted. So one server runs out of memory, it gets restarted, second server gets overloaded, it gets restarted, and a whole bunch of servers were getting automatically restarted, because that was the workaround, right? At which point they had to call in a SWAT team and then start attacking the root cause of the problem. They identified that their memory usage was slowly climbing up and down, up the curve, and there was an out of memory killer which was just killing the process and ending up restarting. The HA thing would kick in and say, okay, your system, your service is down, I'll restart. So that actually resolved that problem before they could actually solve the issue. So if you need to do it, but collect the data so that you can actually debug and fix the root cause.
Somehow restart always that works. Almost always.
Almost always works. Yeah.
Yeah, we haven't yet reached that level of priority in the eyes of our production support teams. They just go in a panic mode and they push the restart switch, and before anybody's even there, it goes in a black hole until it reappears mysteriously, the same problem, and then again the restart. So there are bugs in the code that now we don't even know when. It's like an earthquake. We don't know when it will happen again. So, literally, yeah, and I'm just like, why can't we invest some time and money in tools?
Yeah.
But the company is moving so fast that they just don't have that patience to do it.
Right.
It's just a cycle. You know.
Yeah, I think incrementally, if you can just keep adding instrumentation to start detecting those things, it would help till you actually have. I don't think any company has time to dedicate to debug tools, right? And it has to be an organic process of slowly you start adding, and at some point you say, okay, this has to be a production thing. Your customers will start asking for it when they start self-servicing. So that at that point, you basically will probably have the resources to make it a production.
So these days, production servers typically have dashboards going along with the health, to monitor the health of your production cluster.
We do that actually.
Yeah, so if not anything, you at least have a dashboard to look at things, monitor performance, so that you can preemptively, if it's hitting like a 85, 90%, you sort of like.
Actually, honestly, there is one incident which happened, and even I work at the same company actually. So there was an incident where we had this memory leak issue, and we were still like debugging it actually. So what we exactly did is, like, whenever we use Splunk for monitoring, so whenever we saw that memory curve is going up, we used to just restart the machine. So it helped us for interim, but long term we figured out the issue and fixed it. But yeah, we do have like all these tools in place. But yeah, sometimes it's still like the data whatever we get will not be enough to really figure out the root causes. But that's a different story, I think. But it happens.
And then it also depends upon the type of business you are in, right? If you want 100% site up or something like that, then you don't have the choice but to restart immediately, and you have the site
Short-term fix, we just restarted.
All right, thank you everyone, and if you have any questions, I'll be here. Thank you.